All right, guys, on page 2, we're about to find the correlation, and it's going to be right here, and it's going to be a big, ugly formula that's going to scare the bejesus out of you. But let's talk about the things that you need in the first place. From the data sets, you need the mean of the explanatory variable, and that is x bar. You need the standard deviation of the explanatory variable, and that is s sub x. You also need the mean of the response variable. So I'm going to write that here, mean of the response variable. That will be y bar. And you need the standard deviation of the response variable, and that will be s sub y. And then one more thing you'll need is n, the total number of ordered pairs. Now, how do you get these things? These two, put them in the calculator as list 1, and you do one variable statistics for L1. For these two, you put the response variable in for L2, and then you just do one variable statistics for L2, and the calculator gives you all of that information, okay, including n, the number of things that you have. Here we go, people. The correlation R is a formula that goes, I'm going to put R over to the side. This formula is so big it won't even fit on the whole line if I put the R there. Ready for this? 1 over n minus 1. So like we did with the standard deviation, we're going to divide by n minus 1. And then I'm going to put this big fancy sum thing here that says I equals 1 to n. That means everything that goes after this, I'm going to get a whole bunch of answers, and I'm going to add them all together. This first one and this second one are multiplied together, and they go like this. X sub I, which means just the first x value and then the second x value, minus x bar over the standard deviation of x. Guys, that's just a z-score. I turn each x value into a z-score. That's all it is. And then y sub I minus y bar over the standard deviation of y. I turn the corresponding y value into a z-score. So I'm multiplying the z-scores together. So look on this one, turn that into a z-score, turn that into a z-score, multiply them together. Get all of those z-scores multiplied together, and you add them up, and you divide. So it's like an average. Okay? Or, I don't think we need to write that. I'm just going to put a happy face so that you guys aren't too mad about what we're doing here. So, here we go. Book example, they've got foot length and height for, I think these are bones from some kind of dinosaur or something, and they're trying to see if there's a connection between, a linear connection between foot length and the height when they see these bones. Either that or it's the height of people. You know what, I'm not really sure. I'm just going to go circle the happy face and move on. Here's what I want you guys to do. Enter the foot length in list 1. That will be our explanatory variable, so we'll call those points x. And enter height in L2. And here's what I want you to do. You got to hit the stat button and then go over to calc, just in case you forgot how to do this, and then do a number 1 for the one variable statistics with L1. And then do the same thing, hit the stat button, arrow over so that you're on the calc menu, and then do number 1, but this time do that with the list 2, so you get all of your x bar and your standard deviation of x from L1, your y bar, your standard deviation of y from L2, and then for either one of them you can pick the n, the number of pairs you have. Okay, next page.